Okay, almost done. That's not that big of a mistake, but man, right? If even I'm losing track. So we have a plus v1 prime squared over there, which was the sine squared term plus the cosine term. So there's my 2. Actually, I have to add it over there, so it become negative 2. There we go. We can move it in that step. Combine it, so I get negative 2 and negative 2. The 2's go out. So v1 prime equals v cosine theta 1. Hooray! So now I got rid of v1. I can just get rid of v1. We eliminate it all the way down. Doesn't that seem reasonable? Doesn't that seem like... Did you beat me to it, Shannon? Did you beat me to it? Yeah, no. It really does. It's the long... Yes. It's the long... No. And... Yes, they would have to... I would try some trig real quick. Just to do it like... Do the triangle, do the... Real fast. Yeah. Okay. So then since we can substitute... Okay. Remember we were looking for k prime. Okay, k1 prime, excuse me. And it had to be k minus k2 prime. Okay. Oh, wait, what? No, we got v1. It doesn't have to be that. It just has to be 1 half m or m1 v1 prime squared. So it's just 1 half m v squared cosine squared theta 1, and they said to write it in terms of k1. That's it. So here's the answer to A. k1 prime, and they wanted this monster algebra. If you wrote it down or watched the whole videos, plural, see if you can cosine squared theta. Hey, that means because kinetic energy is conserved, k2 prime must also be equal to that one times the sine squared of the angle. Oh my goodness. Because that's all what's left over, and it said elastic, right? So they better add together and get 1. Okay. So then solve k2 prime. You bet. Oh look, I did it. Math. Okay. So then it's actually not that many steps for part C. And you can either watch the video after I post it, or if you followed along, fantastic, you can probably get finished. Just took a little more than 15 minutes. Okay. So here's what you do. You take those momentum equations, okay, simplified, so I divided off the masses. So where v equals v1 prime cosine theta plus v2 prime cosine theta 1, cosine theta 2, and then 0 equals v1 prime sine theta 1 minus v2 sine theta 2. Take those two equations, square them so that you get thetas, and then you get a relationship between cosine theta 1 and cosine theta 2, or theta 1 and theta 2. And you can actually prove. Let me see how many trig identities. So you square them and add. Okay, and now that you have the kinetic energies and you have the v squared and the v1 prime squared, v2 prime squared, etc., you can combine it. Let me check how they simplified this. I think they are using a trig identity. Okay. So I'll give it to you. And then you can show that theta 1 plus theta 2 equals something special that you can probably guess. Our trig identity physicists love to use these like they're just nonchalant nothingness. But I have no idea where they got this one. Which is why, so if they wanted to see some steps out of you, they would have to give you this identity. The cosine of an angle times the sine of another angle minus the sine of the same two angles multiplied together. Equals the cosine, somehow, of the two angles added together. I'm not sure how I could prove that, but they claim that is true. And based on my trig experience, it very probably is. Okay. So you'll need that ID to finish problem 3. Once you use that, like you collect your term, you square both terms, collect your terms, use that, and it's pretty easy. And the other two, problem 1 and problem 2, are not that bad actually. Nope. You use energy conservation as best you can. You might need some forces, some Newton's second law equations, and they're okay. Alright, any questions? Sure. I can. I can even zoom out. I can also, is that good? Oh, there you go. I can print this I can make this a PDF that goes on our Canvas page. Miss the most, does anybody still need those last steps in my identity? Okay, I'll try to save it online too. Okay, so now we actually have to scroll. Like so.